Okay, we're on the next page, continuing on with factoring. I believe this is 129. Um, so like I said in the other video, really we're going to kind of go backwards. We're going to do reverse distribution. So remembering how distribution works, you have a factor on the outside of your binomial or polynomial, trinomial, whatever it is, and you're going to multiply, and you're going to get rid of the grouping symbol. So this would become 2x plus 2y. But what if I give you the 2x plus 2y and I ask you to reverse distribute it? I ask you to go back and factor out what they have in common. So if you just look at 2x plus 2y, of course you know the answer, it's right above here, but if you didn't, you might say, okay, what do they have in common? What is their greatest common factor? Well, if you look at the prime factorization for 2x, it's 2 times x in a box. 2y, 2 times y in a box. The only thing they have in common is 2 to the first power. It can come to the outside of the grouping symbol, and then essentially you are saying 2 times what will give me 2x. So you have essentially factored out or divided by 2. And then you have a plus sign, and you need to do the same thing with the second term. So 2y, if you take the 2 out, what's left? The y. And the good thing about factoring like this is you can always check your work. You can check your work by distributing back again and seeing, do you end up with the same exact expression that you started with? 2 times x, 2x, 2 times y, 2y. So let's just do a couple of these, remembering that you are factoring out the GCF. So I'm going to just, you don't have to write the GCF process each time, but I'm going to remind you of it in a couple of these examples. 3m cubed, the GCF is 3m cubed. You cannot reduce 3 any lower. 3 is a prime number. 6m squared, that's 2 times 3. m to the second power is the prime factorization. The GCF, we take everything that's in common in the boxes, which is a 3 and an m, and we take it to the lowest exponent we see. This is what we are going to factor out of this expression. So essentially you're asking yourself, okay, if I take 3m squared away from 3m cubed, I divide it out, what do I have left? Well, you have a single m. And you can test it by multiplying back again. If I take 3m squared out of 6m squared, I have just a 2 left. The sign is positive. I've got to get back to a positive 6m squared, and I do. Second example, GCF over here. 2 squared a squared is the prime factorization, and 2 times 5a is the second one. The GCF is going to be what they have in common. That's going to be 2 to the first power, a to the first power. The 5 can't play, and the 2 squared can't play. It's the lowest exponent. So that's what we're going to factor out. Again, you don't have to do this every time, but you need to make sure that you are pulling out the greatest common factor. If you're just pulling out a factor, it's not factored, it's not considered in factored form. So we call these guys factored form. This is called factored form. So you'll know what it is. When you hear me talk about it, you'll know what it is I'm talking about. This guy right here. So let's go back to this problem. If I take 2a out, what do I have to multiply to get to 4a squared? Another 2a. There's a minus sign here. I'm going to need to multiply this positive 2a times a negative to get to a negative, and I'm going to be multiplying by simply by 5. I'm checking my work. 2 times 2 is 4. A times a is a squared. Looks good. And a positive 2a times a negative 5 is a negative 10a. All right, there's another couple things that we need to look at. We need to talk about negative when you're leading, when your highest degree of your term is negative, what we do with that. And then also these last two examples, in example 5 are not written in standard form, and you need to rewrite them in standard form first. So let's look at 4a. It is in standard form, m to the 5th and m to the 3rd. That's good. But the leading coefficient, this 3, is negative. When it is negative, when you pull out the GCF, you will pull a negative GCF out. So you ask yourself, what is the GCF of these two things? Well, if you think of 12 as 3 times 4, and this is only going to have a 3 in the box, the 3 is the numeric portion of it, and we take what they have in common, the m, but to the smallest exponent we see. Now we've got to figure out what's going to go inside our grouping symbol to multiply back to the original problem. So a negative times a positive will give me a negative. I've got the 3. I've got m to the 3rd. I need m squared to multiply back to what I started with. All right. I need a negative when I end up, so this is going to have to be a positive. How can I get from 3 to 4, or 3 to 12, multiply by 4? How can I get from m cubed to m cubed? I'm already there. I don't need any more m's. I don't have to multiply by any m's. I'm going to check my work. Negative 3 m cubed times m squared is negative 3 m to the 5th. Got it. Negative 3 m cubed times a positive 4 is a negative 12 m cubed. And I'm done. These are great because you can always check your work. You can always get back to where you came. So you need to have enough self-discipline to actually do that. These exponents are also in order. So all I need to do now is look at the GCF. I've got a negative coefficient. I need to factor out a negative GCF. 2 will come out. What else will come out? A will come out to the first power, lowest exponent, and B to the first. Again, I've got to fill out my grouping symbol so that I can get my product that I started with. I've taken care of the 2. I've taken care of taking out one of the A's. I need 2 more, and the B comes out. So I don't need to factor out any, leave any B's on the inside. Again, I need a negative times a negative is going to give me this positive guy. So that's going to be negative. I can see that negative 2 times negative 3 will give me the positive 6, and I got the A, B already factored out. So this is my factored form. I want to run through these couple really quickly, at least maybe one of them, and then we'll do one in class. This is not in standard order. So the negative 21x cubed has got to come first. Now you can see you're going to factor out a negative GCF. The GCF is going to be 7x squared. What do they have in common? What's left? How do you multiply 7x squared, negative 7x squared, to end up with negative 21x cubed? 3x. 3x. What about this? I've got negative 7x squared, and when I multiply it in here, what do I have to multiply it by to end up with positive 7x squared? Well, the answer is a negative 1. And you can see that when you go check your work. Negative 7x squared times negative 1 gives you the positive 7x squared that you started with. So you guys try B on your own, and I'll see you next time.